Now, in this session, when we are discussing about evolution of teaching and learning process, I will be explaining you a virtual lab approach which is required for the new methodology which we are proposing. The most important thing about this is our Honorable Prime Minister Sri Narendra Ji Modi talked about few technologies in education which will change the way education is being carried out in India. Out of that, one is virtual labs, and he said, and I quote, "Concepts like virtual labs are going to carry the dream of better education to millions of students who could not read such subjects before, in which lab experiment is necessary." That is the statement, and since then we are literally working on this project for last more than 11 years, and that is how the project is progressing. But now I am going to tell you the challenges which we can have as a teacher in virtual and remote lab development. The basic difference between virtual lab and remote lab is, in a virtual lab there is a mathematical model which is working at the back end, and the simulator is working as if the real experiment is being carried out by the student. While in case of a remote lab development, what we have is a physical infrastructure, but that physical infrastructure is web enabled and can be remotely monitored by any student across the country. That is the biggest difference. Now, what is important is, and that is there in the minds of all the teachers, that what will be the reaction of the students if I as a teacher am not there. We feel that eye to eye contact is mandatory, my presence in the laboratory is mandatory, and that is how the things will move. So, that is the big challenge, and we have to come out of this as far as a teacher is concerned. Now, the next challenge is what is to be covered, because in case of a virtual lab, the physical lab, it should look like a physical lab, but there is no direct monitoring by these teachers. So, what is to be covered in that lab is always a concern for the teacher. The another concern is, of course, the replication. Is it a replication of a journal? That means the students are at their own place because of this pandemic, or maybe after this pandemic when it gets over, and I am sure it will get over soon. The problem is how to use those virtual labs. How do we engage students? Because we feel as teachers that unless and until we are there in front of the students, students will not learn. Now, we need to change this apprehension as far as our role is concerned. The another $1,000,000 question is, how do we evaluate the performance of a student? Is it that the student is really working? Is it that he is just looking at the simulator, or is it that the page is just open and student is not performing anything? How do I evaluate? Because I am away from the student physically, geographically, the student is at a remote place. And the last thing which always be questioned as far as remote triggered labs are concerned, is it safe to operate a plant remotely? What will happen to the plant if anything goes wrong? Is it safe? So, these are the challenges and these are the questions in the minds of the students. In last almost 11 years, we have struggled with all these challenges, and I can tell you with confidence that we have resolved all the challenges which are being put forward to the consortium of virtual labs. Now, the question here is, as a consortium of 12 institutions, and I am going to tell you who are they. These consortium partners have developed various laboratories, but we expect, because India is a huge country and we have many disciplines of engineering and many experiments university wise, the curriculum is different, all the challenges put together, a mere consortium may not serve the purpose of designing experiments from all the disciplines. What we need is, we want onboarding of other institutions also, and that is why this slide is important for all of you. The first thing is, what we need to do in case of developing a virtual laboratory is we need to understand what a student can expect, and we have to design a surprise for him. Otherwise, it becomes a monotonous thing, and there is a concept in the minds of the student that if I can copy from somewhere, for mere submission my experiment is over. Now, we have to, as a teacher, must be one step ahead than the students. The second is baseline understanding of the requirement from the application point of view. In the previous session also, I mentioned we have to go very close to application so that students will understand that there is no difference between theory and practice. They will go hand in hand, and that is why we need to understand where this particular concept will be used in an application, and we have to use that concept. We have to clearly define the LOs, laboratory outcomes or experiment outcomes. Now, these LOs should reflect the job profile. In the demonstration which I will be giving you after this, I am going to show you how the job profile is getting mapped with the LOs so that it becomes relevant. What is important here is your experiment should be relevant, and that is why you have to identify the configurable part of the experiment. Now, this is the beauty of virtual experiments or virtual labs which we have developed, where every student, whenever he or she logs into that, there will be a new challenge. So, no two readings would be same, no two setups would be same, so that randomly at the back end we have developed these processes where randomly new challenges will come up to the students, and we expect whenever somebody is looking at developing the lab, please look at this portion very carefully. Now, if you go to the next part of it, where evaluation. Now, this is very, very important. In my absence as a teacher, how do I evaluate? Proctoring may be a good idea, but then our country is facing a lot of problems, and this is already being reported that students are facing the problem of network and the bandwidth, electricity even. So, all put together, there will be a very, very challenging situation for all of us to evaluate those students. So, we have to identify what is to be evaluated at each stage when a student is performing that experiment, and in what context that evaluation has to be used, because we need to change the context so as to reduce the monotony of the experiment. And when you reduce that monotony, students will get enthused because of use of this type of a technique where context is different for the evaluation. Then we need to mark the points of the events captured as a background for evaluation. Let me tell you one important thing, because virtual labs are very close to the computational tool which you have. In fact, we are using a computer for performing the experiments. So, whatever is happening at the back end can be captured very easily, and that whatever we have captured as a data can be easily used for evaluation, and we need to check and we need to understand which points I can use it for evaluation effectively. Then we need to automate the entire process so as to record important events. Now, what do I mean by this automate entire process? In the previous session, I talked about how much time is available for a teacher so as to give attention to each and every student. And the answer is, I am sorry, no, I do not have that much time. But then the technology will come to our rescue. So, by automating that process, all the events, most important events can be recorded at the back end, and then a framework can be applied for those events so that a learning of a student can be understood by a teacher. Then whenever now you have understood the challenges, you know what to do, but what is important is we have to prepare a storyboard. Now, that's the standard practice which we all have to follow as far as developing a storyboard is concerned. Otherwise, there will be a gap between the development process and the teacher. And if that gap is there, and I am expecting that a teacher is not going to code or program the simulators. There will be some professionals who will be working on our behalf. That is how the understanding is. and that is where you have to prepare a storyboard, explain it to the programmer, critically detail out the expectations so that it will be part of programming. We need to develop adequate theoretical background. Now, what I mean by theoretical background is when you are performing the experiment, a certain amount of theory is being taught before, and we are expecting that students should go through that theory before appearing for the virtual lab. There has to be, and we need to create correlation between theory and hands-on. See, let us understand it is a seamless thing. Theory and hands-on is a seamless thing. There is no gap, absolutely no gap. The way we are talking about theory as a concept, the same theory or the concept can be implemented easily under the regime of virtual labs. So, make sure that there is a correlation established by us as a teacher. Then identify evaluation requirements at each stage and then automate the entire process. But when? I am repeating that statement again here, and the reason for that is now it is in the context of the programming part of it. It should not feel or it should not look like that in programming or in case of database structure, these events are not being taken care by the programmer. So, we have to ensure from the development of project or the experiment versus programming of that experiment. That is the reason this line is here. Now, when you go for this line, let me tell you what are the salient features of virtual labs. It is available 24/7, and here let us understand this lab, virtual lab, is available after the college hours also. That means you are extending your institution hours, learning hours of the student so that the effectiveness would be guaranteed. This is developed in self-learning mode because our focus is not for spoon feeding. Now, as early as possible, we have to ensure that there is no spoon feeding from the faculty member. Student must develop, understand the experiment and perform the experiment on its own. There are innovative experimentation which we have carried out in this entire exercise, and we have developed more than 1400 experiments, and many more are going to come as far as this project is concerned. Now, this project has helped many institutions, and we have received good support and usage record by many institutions about the usage of this experiment. There is a radical change in teaching, learning and evaluation process, because now we have to understand that in case I am absent, still the practical can go, still the student can perform the experiment, still he will be tracked, still he will be evaluated. For me, the data which is generated while performing the experiment will be useful for me, and I can access that data afterwards also. In case of remote triggered laboratories, our salient feature is you can maximize the usage and reduce the cost of education. Let me clarify few things here. When you are saying that I am having a remote triggered lab, that means you have costly equipment. Remote triggered labs are not to be used for routine experiments. That is what we have understood. So, when the instrument is costly and when a particular institution is buying that, it becomes the mandatory requirement for that institute to maintain those equipment also. If you look at high cost equipment in many leading institutions across the country, and the number of hours this usage of that particular equipment is concerned, you will find that they are minimally utilized. Why other students from other institutions be deprived of such type of a facility? May not be physically there, but being virtually there, they can still operate the instrument, and we have already and I am going to demonstrate you a remote triggered laboratory also. We have already demonstrated that such type of things can increase the usage of the equipment and reduce the cost of education, because it is now divided. The cost of instrument is now divided, and that is where we expect the help from the teaching community so as to develop an cooperative model for developing a question bank and which can be incorporated in virtual lab, which can challenge the students, and because of that the evaluation becomes effective. So, how to use the virtual labs? Virtual labs are basically used through internet. You can have n number of remote users and these labs are hosted on the cloud. So, 24/7 these labs are available. So, who are there in the lab? Basically you will find the physical lab will look like this, that few pilot plant is there, some electronic equipment are there, or some chemical and biological labs are there, but these labs would be stationed in that particular institution. Now, if I can convert these labs into a model, even if I do not have physical lab, I still can use that lab and practice on the model, and the model is very close to the real application, and that is what is called as a digital twin in an education system. That is what we all are talking about. Industry is talking about in terms of industry 4.0, we are talking about education 5.0. So, what are the broad areas? You name the area in engineering and technology, you will find there are labs from our consortium. The labs spanning from electronics and communication up to the chemical sciences and physical sciences lab, you will find most of the labs quite interesting. And while using these labs, you will find that the students are literally using those labs with enthusiasm, and they are drawing or understanding many concepts which are required of the office hours. So, who are the partners? These are the participating institutions. These are 12 institutions, out of that 8 IITs, triple IT, 2 universities like Amruta and Dayal, 1 NIT Surathkal, and my institution, College of Engineering, Pune. We are participating in this project, and this project started in 2009, and still this project is continuing. This project has proved beneficial in this pandemic, because when colleges were not running, labs were locked, students were locked at their home, teachers were locked at their home. How to take the academics forward was the question. We said, yes, on cloud these labs are available, let students use those labs and see what is happening there. And you will see here that there are few upcoming features in phase 4 of these labs. We are adding experiments will have a configurability, and the meaning of the word configurability means every time as if the student is performing new experiment. So, new situation will come, new set of readings would come, and then the student will feel that yes, I am performing the experiment, there is no scope for copying. The pre and post test will be uploaded from a dynamic question bank. Currently, pre and post tests are basically from the static, that means minimum 5 questions all, and once you know the question, you lose the interest in solving those questions. The most and critical part of it, which will be part of the upcoming feature, which is activity tracking of the student to a certain learning style of a student. Now, faculty members must realize this aspect, that though we all are developing the virtual labs, the efficacy and effectiveness of the virtual lab depends on whether students are using those virtual labs constantly, they are learning from those virtual labs, and we are getting a feedback wherever they are missing a point, so that we can relearn or redevelop these labs or these experiments. That is why the feedback is required, but that feedback has to be in an automated format, otherwise it would be difficult, and that is where we will be developing generation of a report card accessible to student and a subject teacher for every experiment. The demonstration which I was talking about will talk about all these aspects which are already being implemented in one laboratory in College of Engineering, Pune, and that is how we want to ensure that these labs would become essentially or important. There will be pre-recorded notes like the notes which we are talking about today, or the notes from the NPTEL or from SWAYAM, which will ensure that the theory portion of the lab is covered somewhere. The students have done that on their own and now they are performing the experiment. So, ultimately what we are talking about is generating the blueprint of a student, but it has to be mapped with the job profile. Now, the point here is the training and placement department of many institutions are worried about what to be showcased as a profile. But now if I say that a particular student has done these many activities and these activities are mapped with a job profile, and the proficiency of the student would be a baseline for whether to select that student or not, and not only the grade report which is available with the student. So, that is the radical change which is going to happen, and industries I am sure will be very happy confirming that we are getting a right kind of students, those who have done good in their academics continuously and they know what is a job profile. And lastly, we are developing a dashboard for individual and a batch of students for continuous assessment purpose, because we are talking about outcome based education. When we are talking about outcome based education, it should not happen that we are bothered because of the data entry. The data should get populated or data should get captured at the back end in a very, very systematic manner, not like a policing, and that is what has to happen, and that is what is our dream also. If you look at the usage, more than 3.6 million students from 1st Jan 2020 till date, I have already used labs from College of Engineering Pune. Similar is the situation from other institutions also, and roughly more than 15 million students have utilized this facility in the pandemic, and it has proved beneficial for the student. Just to give you an idea about how the labs are being used. Now, in the next session, I will be demonstrating you a virtual lab, and then I will be demonstrating you the remote triggered lab, both the labs. The remote triggered lab, the pilot plant, a boiler and heat exchanger is there in College of Engineering Pune, and sitting here I am going to operate that pilot plant and tune the PID controller, and I am going to demonstrate you that, and that is very, very important. And I must acknowledge the support received by my consortium from Ministry of Education under this project, very ambitious project, National Mission on Education through ICT, and we will continue developing those labs, and we will make sure that these labs will be made available to students from the remote locations also who are deprived of the education. So, let us not divide country as far as the digital divide is concerned. Let us work together to ensure that every student of this country should get the same type of support and infrastructure, either through virtual or through remote, so as to make quality engineers. Thank you so much.